Hello everyone, we are now moving on to our next topic, topic 3, which is all about graphing quadratics. These first two lessons, 10 and 11, are going to be surrounding standard form. So today we're going to be looking at key features of standard form quadratics. So you're going to be able to identify key features not only from a graph, but also from a quadratic in standard form. Lesson 10 is all about setting up to graph, and then our next lesson, number 11, that will actually be when we graph. So there's going to be no graphing in this one. So the first concept is representation of a quadratic function. So a function is a quadratic function if its equation can be written in the form y equals ax squared plus bx plus c. You guys are already familiar with this because you've been using it to do some solving with factoring in the quadratic formula. All quadratic functions are transformations of the parent function defined by y equals x squared. So this is how all quadratic functions are built off of. The graph of a quadratic function is called a parabola. Now a parabola is special because it is U-shaped. It'll always be shaped like a U, whether it be right side up or upside down, it'll always have a U shape to it. To be able to graph a quadratic function, we are going to need to know how to identify key features of it. So that's what we're going to take a look at first, is identifying key features of a quadratic function in standard form given a graph. So as you can see here, we have a graph. And I have a lot of things, some blanks to fill in about each part of the graph. So let's start down here at the very bottom. So right here, this point that is the very bottom of our parabola, this is our vertex. And we're going to represent vertex as a point xy. So there is our vertex. Now, connected to the vertex, we're actually going to come right up here to the top. As you can see, there is a dotted line running down the middle of our parabola. It is connected to the vertex, and this is called the Axis of Symmetry. Now, the big thing to note with the Axis of Symmetry, it is the x value of the vertex, and it's going to be written as x equals whatever the x value of our vertex is. A few more things, part of the graph. These guys right here that are intercepting the x-axis, these are our x-intercepts. But there's also another common name that you're going to see, and that is called the roots. So when they ask you for the roots, they want the x-intercepts. And then the final little bit of our graph is this point right here, which is our y-intercept. Y-intercepts don't have any extra special names like the x-intercepts do, so they are just known as the y-intercept. Now, that's all that we can identify from a graph. But there are other pieces and other key features that we're also going to need to identify. So some other key features. You need to identify if it's opening up or down. So that's all you just have to ask yourself. Is it opening up or down? And it's really easy to tell from a graph if it's opening up or down. Then you need to be able to identify if the vertex is a minimum or maximum. And yes, it is related to the vertex. So it is the lowest or highest y value from the vertex. Then we have domain and range. What's nice is domain is going to be the same for every quadratic. So the domain is going to be from negative infinity to positive infinity. And as I said, it's always going to be negative infinity to positive infinity. Now, the range, it depends on what your maximum and minimum is going to be. So, with your range, if it is a minimum point, then you're going to have bracket vertex y, comma, positive infinity. If it is a maximum, parentheses, negative infinity to vertex y bracket. So it all, range always depends on what your maximum and minimum value is going to be. Now that I have talked about each of these key features, we're now going to explore how to find them from a graph and from an equation.